This is our part 2 of scientific notation. Make sure you have your spiral open to page 15 so you can follow along. And this is a flip page. So we had talked about how many molecules of sucrose were in every teaspoon of table sugar. The number, that really big one that's written up there, is written in standard form because it's really big. It's not written in scientific notation. We can change this really large number from standard form into scientific notation by using the rules from the earlier pages. So the first rule is we must move the decimal point to create a number between 1 and 10. Where is that decimal point if we don't see it? And I'm just going to write down here as neatly as I can with my finger at the end. Sorry guys, I left my stylus at home at the end. So there it is. Now we wrote in the decimal point, and if you want to use a pen or a colored pencil, you can. So now we're going to put the decimal point in a spot on here that's going to create a number between 1 and 10. So where are we going to move it to? Between which two numbers does this new decimal point have to go? It's going to have to go right there, right in between the 3 and the 3.5. So 3.35. That's creating the new number. And now we have to move the decimal point from here all the way over to where it is. So I'm going to go by threes. 3, 6, 9, 12, 15, 18, 21. So we went over 21 times. That's going to be our exponent. So keeping in mind, we need two things for scientific notation. We need a number between 1 and 10, which I just created, and that is 3.35. And it's going to be multiplied by an exponent by a power of 10, so 10 to the 21st power. And this here, 3.35 times 10 to the 21st, is how you would write that really big number in scientific notation. So we're going to do some practice on that flip page. Okay, so here is on the flip page. So now we have some practice problems to do. So the first one we have is 1,200,000. So we are going to put the decimal point, because it's at the end if we don't see it. So it's at the end. And we're going to move it so it creates a number between 1 and 10. So I'm going to move it so it's between the 1 and the 2. So it's 1.2. And I'm going to slide the decimal point over 3, 6. So it went over 6 times, so it's 1.2 times 10 to the 6th. Let's take a look at the one below it. 35,986. So where's the decimal point? We don't see it. It's at the end. So now we need to put it someplace so it creates a number between 1 and 10. That would mean that we would want to put it between the 3 and the 5. So we have 3.5, but we have to write 986. You got to write all those numbers out. Times 10. And how many times do we move it? 3, 4. Times 10 to the 4th. Sorry, it's so messy. 3.5986 times 10 to the 4th. Let's take a look at the one. Let's go to the one that's up top, 82 million. So creating a number between 1 and 10 would be 8.2 times 10. And how many times is that decimal point getting moved over? 3, 6, 7 times 10 to the 7th. You've got two that are starred, a 10 and a 0.08. Those are two challenge problems for you. I'm going to jump down to the scientific notation to standard form. So here we have these examples here are written in scientific notation. Now we want to make them into really big numbers. So, how are we going to do that? We've got 2.3 times 10 to the fourth. As Alex had mentioned in class, piggybacking on what Jeremy was saying, this 10 to the fourth tells you how many place values we need to move to the right. So you have 2.3 times 10 to the fourth. 2.3, and we're going to be moving it 4 places. 1, 2, 3, 4. Yep. So now we have 23,000. 10 to the fourth, 4 place values, move it over 23,000. Let's take a look at 1.085 times 10 to the sixth. What does that 6 tell you? It's telling you to move it over 6 places. We have 1.085. So we're going to move it over 1, 2, 3, and we have to fill in the rest of those zeros. So we have 1,085,000. So I want you to try doing these practice problems. We do not meet on Wednesday, but give these a shot, and we'll see how you're doing when we come back on Thursday.